Hi class, today we're learning about solving quadratic trig equations. So this is our last note on trigonometry in high school until we get to calculus, that's of course. And so whether you found this chapter difficult or rewarding, this is the last thing we're doing. It's a rather short note, and it kind of just combines our knowledge of quadratics, how to solve a quadratic equation, with trigonometry, so how to solve a trigonometric equation. Okay, so if you have your note, you can get that going here. So let's just first of all remind ourselves how to actually solve a quadratic equation. Okay, so you can solve a quadratic equation by, number one, first rearranging it. Okay, you need everything together on one side. So, because you can't isolate x here. So you need it in the form x squared minus x minus 2 equals 0. So once you have a quadratic equation in that form, you have two choices. Either you can factor if possible, or you can use the quadratic formula. So if you're going to factor, you just think of two numbers that multiply to -2 and add to -1. So in this case, that would be x minus 2 and x plus 1 equals 0. So from there, we can determine that the solutions are x equals 2 and x equals -1 are the solutions. Okay? Quadratic formula would be x equals minus b, so minus a -1 is 1, plus or minus the square root of b squared, so minus 1 squared, minus 4 times a, so 1, times c, so -2, all over 2a, so 2 times 1. So in this case, you would get out, again, x equals 2 and x equals -1. So either way works. So when you have a trigonometric equation, you can solve it the same way, but then when you get to the actual solving part, you have to use trigonometry. So how do we solve sine squared x minus sine x equals 2? So almost the same equation. It's just that instead of x's here, we now have sine x's. So the first thing we do, same thing as we move everything over to one side. So sine squared x minus sine x minus 2 equals 0. Okay, so now you can factor this. Okay, so you can think about this, that this is just like you have a squared minus a minus 2 equals 0, where a is equal to sine x. Okay, so this would factor to a minus 2, a plus 1. So this is going to factor to sine x minus 2 and sine x plus 1 equals 0. Okay, so now you have two options. You can solve this one. So now this is where your trig knowledge comes into play. So this would give us sine x equals 2. So now we have to solve this. Well, we know that the maximum of a sine curve is 1. So there actually is no value of x for which sine x could be 2. So this is inadmissible, and there's no solutions from that part. Then we have from this, sine x is equal to -1. So it's sine x equal to -1, not x equals -1. And we know that if we think about the Cartesian plane, sine x is equal to -1 when we're down here. So x is equal to 3 pi over 2. Or you can just think about it, when is sine x at its minimum? And that's at 3 pi over 2. So that is the solution. So the major idea here is that you can either factor or use quadratic formula to solve just like a quadratic. And then once you get it to that point, you have to use your trig knowledge to solve after that. So here we have another example. 2 sine squared x minus 3 sine x plus 1 equals 0. So we know that it's a quadratic because of this sine squared. Okay, so it helps me to do it to make it look like a quadratic first. So I just say this is like us having 2a squared minus 3a plus 1 equals 0. It's just that our a is actually equal to sine x. So if you were to factor that, you would use decomposition, right? What multiplies to 2 and adds to -3. So that's -2 and -1. So you'd have 2a squared minus 2a minus a plus 1 equals 0. So you'd common factor 2a, bracket a minus 1, subtract bracket a minus 1 equals 0. So you get 2a minus 1, a minus 1 equals 0. All right, so we can do that back over here with our sign. So we would have 2 sine x minus 1 and sine x minus 1 equals 0. So now we have to find when sine x is equal to a half. Okay, so using our special triangles, we know that that's true when, so using our methods from linear, we can find that x is equal to pi over 6 from a special triangle. But then it's also going to be in quadrant 2 with the same related acute angle, so you get x equals 5 pi over 6. Okay, just remind yourself here, sine is positive in this quadrant, and this quadrant, the related acute angle is pi over 6. From a special triangle, that's how I came up with those two answers. Okay, now I also need to solve for sine x equals 1, and that's at its maximum, so that occurs when x is equal to pi over 4. So there we go. Oh, sorry, not pi over 4, pi over 2. So all three of these answers are solutions to that quadratic equation. All right. Okay, next example. Okay, now you might be like, how do I do this? But notice that this is already in factored form. So if sine x plus 1 times cos x has to equal 0, then that means either sine x plus 1 has to equal 0 or cos x has to equal 0. So you actually don't have to do any work in the quadratic sense because it's already in factored form. So something times something equals 0, one of those two things has to be 0. So this is sine x equals -1. So then that's when x is equal to 3 pi over 2. And here cos x equals 0. That happens when x is equal to, so think about this, pi over 2 and also 3 pi over 2. But, you know, that's just a repeating answer from before. So then, therefore, your final answer is x equals pi over 2 and 3 pi over 2. That's the solution to that equation within the first 2 pi. All right, last two questions here. We're going to actually have to use some trig identities to solve these. Okay, so use a trig identity to create a quadratic equation to solve for the following equations. Solve for between 0 and 2 pi. Hint, we want all the terms to contain the same trig ratio because for us to be able to factor, they need to be all in the same terms. So it's a problem here that we have sec squared and tan x. So we want this all to be either in terms of sec or in terms of tan. Well, sec is a reciprocal function, so it's probably that one that we want to replace. So you have to go back to page 416 and look at that huge list of identities that we know, and you'll see that sec squared x can be replaced with 1 plus tan squared x. That is a known identity. So if we put that in here instead, we'll have a quadratic equation in terms of tan x. So then we'll be able to solve it. So 2 bracket 1 plus tan squared x, close your bracket, minus 3 plus tan x equals 0. Okay, so this doesn't look very good. We want to make this, we want to expand this, collect like terms, and put it into the way that looks like a quadratic. So this will become 2 tan squared x. And then this 2 minus a 3 will become minus 1, but we want to put the plus tan x first. Minus 1 equals 0. Okay, so this is where I like on the side, again, write it in terms of a. So this is as if we had 2a squared plus a minus 1. So can you factor that? Okay, so this is actually the same factoring pattern as before. So this would just, when you factor this, you would get 2a minus 1, a plus 1, so where a is equal to tan x. So now you can just sub that knowledge in over here. Okay, so instead of 2a, we have 2 tan x minus 1. And instead of a, we have tan x plus 1. And we still have to write the equals 0. So now if this times this has to equal 0, then one of these two factors has to equal 0. So our options are either 2 tan x minus 1 equals 0, which means tan x equals a half, or tan x plus 1 equals 0, which means tan x equals negative 1. Okay, so now we have to dig into our knowledge of quadratics. When do we have this that happens? Okay, in the first 2 pi. So let's think about tan. Okay, if I'm doing this first one, tan is positive in the first quadrant and the third quadrant, so I'll have 2 different answers. And I actually have to use my calculator for this because although 1 and 2 are both numbers in a special triangle, that's never represented as a tan. It's only a sine or cos. So I use my calculator to do the inverse tan of a half, and it tells me that this is 0.46. So that's my first value for x. And the second one is just going to be pi plus 0.4x, so that's 3.60. Okay, and then where is tan x equal to negative 1? Well, that would be in this quadrant, directly right in the middle. What would cut that in half? And in the middle here, what would cut that in half? Or you can think about it as from a special triangle. So x3 then is equal to pi minus pi over 4, so 3 pi over 4. And x4 then would be 2 pi minus pi over 4, so 7 pi over 4. Okay, so there you have your 4 solutions, 1, 2, 3, 4. And it's totally fine that these are decimal and these are exact because these we were able to use a special triangle and use exact values. So we do that when we can, but here we were not able to do it with an exact value. Okay, one more example. So I encourage you to pause the video and try to find out how can we write this equation so that everything is in terms of just 1. So is it easier to change sine x into something with cos, or is it easier to change cos 2x into something that only involves sine? So pause the video, take a look at page 416 and see if you, or your note from Trig Identities, and see if you can figure out what I'm going to do and what I'm going to replace. Okay, hopefully you actually did that. Cos 2x is what we're replacing. And we're replacing it with 1 minus 2 sine squared x. Because if I put that in instead, then it creates a quadratic equation with only sine. So I get 3 sine x plus 3, 1 minus 2 sine squared x equals 2. So to solve this, I need to have something that looks like a quadratic. So I need to expand this bracket, move this 2 over to the other side, and collect like terms. So what I'm going to end up with is 6 sine squared x minus 3 sine x minus 1 equals 0. Okay. You might say, well, how did this become minus 3 sine x? Well, when I multiply this through, this 3 times this minus 2, I would have gotten minus 6 sine squared x. And we never really want our a value out here to be negative, so I just multiplied through by negative 1 so that this leading coefficient is positive. Remember, we always want a positive leading coefficient. Okay, so this is just of the form 6a squared minus 3a minus 1 equals 0. So at this point, I'm not going to factor this, don't really feel like it. I'm going to use quadratic formula instead. Okay, so here is where this is a big, big, big problem that people have. Normally, quadratic formula is x equals, and we're solving for x. But remember, in this case, we're actually solving for sine x, not x. So when you set up your quadratic formula, it has to be sine x equals, and then you put the numbers, not x. Okay, this is not the final step. It's finding the values for sine. I'm putting that in red because that is a big source of error. Okay, so we have negative b, so 3 plus or minus the square root of b squared, so 3 squared, which is 9, minus 4 times 6 times minus 1, all over 2 times 6. So you get that sine x is equal to 0.73. Okay, and you get that sine x could be equal to negative 0.23. So now you got to, next on the page here, actually solve these, okay? This is the step that gets people confused. You actually have to go now and solve these. You're not done. Okay, so sine x, if it's 0.73, that means it has two options in those two positive quadrants. And this guy has two options in these two negative quadrants. Okay, so you're going to have 4 different answers. So to find beta, you just do the inverse sine of 0.73, and you get that beta is equal to 0.82. So then x1 is 0.82 because it's just in the first quadrant, and x2 is pi minus beta, which gives us 2.32. Okay, here we find our beta by inversing the sine of 0.23. Okay, gives us our beta of 0.2321. And so then our x3 is pi plus beta, which gives us 3.37. And our x4 is 2 pi minus beta, which gives us 6.05. Okay, I'm not writing all the steps of like pi plus beta because that's review at this point. I'm just trying to focus on the new learning for today. So I hope you guys can kind of see what's happening here. But please highlight or star this section where you're doing quadratic formula, because I can't tell you how many times I've had students just say x equals 0.73 minus 0.23 and just stop. Okay, those aren't the answers. These are. You have to go through and do the actual trig. So if you haven't drawn or found a beta at any point, that should be a hint that you're missing a step or completing it too quickly. Okay, guys, so that's it for trig. I'll miss you. I love those trigonometry questions. So much fun. But thanks for watching. Hope you learned lots.